So, today we are going to talk about using trig identities to solve equations. The first thing you always want to do is set the equation equal to 0. Then you want to substitute any identities if it's possible. You're not always going to use trig identities to solve the equations. If it's possible, you want to factor out any common trig functions. Like sometimes you can factor out a sine or a cosine. Then you want to set all the factors equal to 0 and use the inverse trig function to solve for the missing value, x or theta, however it's written, in the equation. So, we'll try an easy one first. So I'm going to solve all my equations on the interval 0 to 2 pi. Starting at 0 and going to 2 pi. So I have cosine theta plus 1 is equal to 0. So I have my equation already set equal to 0. Now I want to get cosine theta by itself. That's always your goal, is to get that trig function by itself once you have everything set equal to 0. And you can't factor that, so I'd have to subtract 1 on both sides. So I get cosine theta is equal to -1. Now I have to use my beautiful unit circle, what you guys love so much, and figure out when cosine theta is -1. So if I'm looking at my unit circle, here's my beautiful unit circle that I took off another piece of paper. I want to know when cosine theta is equal to -1. And you guys should remember the points go cosine, sine in alphabetical order, just like x, y. Cosine goes with the x values, sine goes with the y values. So I want to know when cosine theta is -1. And if I'm looking at my unit circle, I see that cosine theta is -1 at pi. And I don't have a -1 anywhere else for my x values on the unit circle. So I know theta would equal pi. And that's my answer. So I want you to try do sine x minus 1 equals 0 on your own and bring it to class. Let's try to do a more difficult one. That's the one you're doing for class tomorrow. Cosine 2x equals cosine x. So you should identify that cosine 2x is a trig identity. And you have the trig identities that I gave you in your notes, but I'll also show them to you. Cosine 2x could be cosine squared a minus sine squared a, 2 cosine squared a minus 1, or 1 minus 2 sine squared a. Since I have a cosine on this side of the equation, I want to use a cosine, something that only has a cosine in my identity. So I'm going to substitute in 2 cosine squared a minus 1 into my cosine 2x. So cosine 2 cosine squared x minus 1 equals cosine x. So I want to get everything set equal to 0. So 2 cosine squared x. I'd have to move my cosine x over to the other side. And they would not combine because that's a cosine square and that's a cosine. So I have 2 cosine squared x minus cosine x minus 1 equals 0. This is a quadratic trig function. Fun, right? So, if I were to think about this as 2x squared minus x minus 1 I want to factor this the same way. I'm just going to have cosines in front of my x's instead of just x's. So if I were to factor this quadratic function, I'd have to multiply to 2x squared, so that'd have to be 2x and x. I have to multiply to 1, that's only 1 and 1. Then you'd have to figure out your signs, and when you have a number in front of one of your x's, you have to do the outers and the inners. So if I checked my outers, I would get 2x. If I checked my inners, I'd get 1x. And I want a negative x when I add these two. So whenever I get a negative x, I would want a negative 2x and a positive 1x. So that would have to be negative 1 and a positive 1 there. So I'm going to do the same thing. I'm just going to add my cosines in front of my x's over here. So I have 2 cosine x plus 1 and 2 cosine x, nope, sorry, just cosine x, cosine x minus 1. So it's the same thing, I just put cosines in front of my x's. Now since I have two factors, I want to set both of those factors equal to 0. So I have 2 cosine x plus 1 equals 0. And cosine x minus 1 equals 0. So again, I want to get my cosine function by itself for both of these. So this one, I would minus 1 on both sides. So 2 cosine x equals negative 1, divide by 2. So I get cosine x is equal to negative 1/2. On this one, I'd add 1 on both sides. And I get cosine x equals 1. So I have to look on my unit circle to figure out when cosine equals negative 1/2 and when cosine equals 1. So if I'm looking at my unit circle, I want to know when cosine equals negative 1/2, that would be at 2 pi over 3. And it will also be at 4 pi over 3. So I have two solutions for my x when cosine x equals negative 1/2. So for this one, x is going to equal 2 pi over 3 and 4 pi over 3. Because on my unit circle, that's when, whoops, that's when I got cosine to be negative 1/2. And I also want to use my unit circle to figure out when cosine is 1. So if I'm looking at my unit circle, when's my x value 1? The only one I'm going to have on the interval from 0 to 2 pi would be at 0 and at 2 pi, but I'm not going to include 2 pi because that's what I said in my directions. So x would equal 0. So you end up having 3 solutions for that one. And you can write them in the squiggly brackets. You don't have to. But it's nice and neat if you do, because all your solutions would be in one spot. So I have 0, 2 pi over 3, and 4 pi over 3. I want you to try sine 2x equals sine x. And bring that to class tomorrow as well.